Hey, what's up guys? Welcome back. In this video, I'll explain you how to choose a good robot chassis for building your car robot. Now, you can purchase the robot chassis from online websites like Amazon.com, or you can also purchase this robot chassis from any electronic hardware store. So guys, as you can see, I've already gone to Amazon.com, and after searching for car robot chassis, these are the options that I've got. Now, out of the multiple options that are available, I have opened two results over here. If we look at the first robot chassis, then it consists of one single plate. You can see the transparent plate over here. It consists of two DC motors which are fitted to the plate, and it consists of a small wheel in the front. This is one of the ideal chassis that you can purchase if you are a complete beginner to robotics and embedded systems. Next, if we look at this second chassis, then it consists of one upper plate, one lower plate, and it also consists of a spacer for maintaining space between the upper and the lower plate. But guys, as you can see, this chassis consists of 4 DC motors, and we only have a requirement for 2 DC motors. If you purchase this chassis, then you have to purchase 2 motor drivers as well. The robot chassis that I am using consists of one upper plate, one lower plate, and 2 side plates. The DC motors are basically fitted inside the robot chassis arrangement. I purchased this robot chassis from a robotics store in my city. Now, even though the robot chassis that I am using will be different from yours, the construction of all the robot chassis is almost similar. So after watching the construction that I'll be doing, you will get a clear idea of how to construct your robot as well. Now guys, if you want, you can browse through the multiple robot chassis that are available on Amazon.com, and you can basically choose the robot chassis that best suits your need. So guys, that's it from this video. In the next video, I'll explain you the different components that we require for building a robot. Hey, what's up guys? Welcome back. In this video, I'll show you the parts that we require for building a robot. So first, for building the robot, we require the chassis. So the chassis that I have consists of one upper plate, one lower plate, and 2 side plates. Next, we require a screwdriver for building the robot. After that, we will require some screws. The specification of the screws I'll show you in the later videos. One caster wheel, one spacer for maintaining space between the 2 plates of the chassis, 2 DC motors, 2 wheels, 2 DC jack connectors, 2 battery snappers, 1 motor driver, an Arduino Uno, 1 USB, a minimum of 3 to 4 batteries, and male to female wires. So guys, these are all the parts that we require for building a robot. Hey, what's up guys? Welcome back. In this video, I'll explain you what is a motor driver and how to choose a good motor driver. So, a motor driver is a breakout board which consists of a motor driver IC. I am using a motor driver breakout board which consists of an L293D IC. A motor driver circuit board is used for running the motors. It is like a current amplifier, and the main purpose of the motor driver is to take a low current signal and convert it to high current signal so that it can run the motors. The reason why we require a motor driver is because components like motors cannot be connected directly to the Arduino as they do not get sufficient power from the Arduino. So we basically connect the motors to the motor driver first and then supply power to the motors using a battery through the motor driver. Now, since I've taken many workshops on embedded systems and robotics, here are 3 of the motor drivers that I have used. All the 3 breakout board uses an L293D IC, which is a motor driver IC. The L293D IC is a 16-pin IC, out of which 4 pins are input pins and 4 pins are output pins. Pin number 2, 7, 10 and 15 are input pins, and pin number 3, 6, 11 and 14 are output pins. You can also see it consists of 4 ground pins, that is pin number 4, 5, 12 and 13. Pin number 1 and 9 from this IC is called as enable pin, which requires 5 volts of power for operation. Pin number 16, which we can call as VCC pin, also requires 5 volts of supply. And at pin number 8, we need to give external power between 5 to 12 volts. That is, we need to provide external power using a battery or an adapter. Now, since we are using this motor driver circuit to control a robot, we will require a battery instead of an adapter. Now, if you are using just a motor driver IC, then you have to do all the connections by yourself on the breadboard first and then connect the entire circuit to the Arduino. So, instead of doing the entire connections by yourself on a breadboard, it is better that you purchase a motor driver breakout board, as the motor driver breakout board consists of sockets in which we have to connect the input wires from the Arduino, the output wires from the motors, and it also consists of a power supply socket where we can directly give power from the battery. Now guys, as you can see in front of the screen, there are 3 motor driver breakout boards, and in all the 3 motor driver breakouts, you can see that there are pins or sockets to connect the input pins from the Arduino, and there are output sockets to connect the DC motors. There is also a power socket where you can connect the external battery. So out of the 3 breakout boards which are present, I'll first explain you the breakout board which is there on the left hand side. Now if you look at the first motor driver, then it consists of 3 green sockets, 2 at the bottom and 1 at the top. It also consists of 4 data pins on the top left side. The input pins of the L293D motor driver IC, that is pin number 2, 7, 10 and 15, can be accessed from the top left side over here at A1, A2, B1 and B2. To these pins, we will provide inputs from the Arduino's data pins. The 2 green sockets at the bottom are for connection to the DC motors. So, the output pins of the motor driver IC, that is pin number 3, 6, 11 and 14, can be accessed from these green sockets. Each socket consists of 2 holes in which we have to insert the DC motor wires. And you can also see the green socket which is present on the right hand side is used to supply external power to the motor driver using a battery. Now, if we look closely, then there are 2 more pins for VCC and ground. So, at the VCC pin, we had to provide a supply of 5 volts from the Arduino. That is, I had to supply power from the 5 volt pin of the Arduino to this VCC pin. And I also had to connect 1 ground pin to the ground pin of the motor driver. So guys, the disadvantage that I found of using this motor driver is that I also had to give 5 volts of supply from my Arduino to the VCC pin of this motor driver. Now, if we look at the second motor driver over here, then it consists of 5 green sockets. The input pins of the L293D IC are connected to the top green sockets which are labeled as M1 in and M2 in. So, at M1 in and M2 in, I had to connect the inputs from the Arduino. The output pins of the motor driver are connected to the bottom green sockets over here, which are labeled as M1 out and M2 out. So, to these sockets, I have to connect the DC motors. You can also see that there is one more green socket on the right side, and to this green socket, I had to give external power using a battery. The advantage that I found of using this motor driver is that I did not have to give 5 volts of supply separately to this motor driver breakout from my Arduino, because the circuitry of this breakout board is made in such a way that the VCC and the enable pins gets the required 5 volts from the external battery itself. So in short, the motor driver basically converts the incoming supply from the battery and give 5 volts of power to the pins that requires 5 volts. And if you look at the last motor driver, then this motor driver is more advanced than the other two motor drivers. It consists of D1, D2, D3 and D4 pins, which are connected to the input pins of the L293D IC. And as you guys would have guessed, these pins will be connected to the Arduino's data pins. The DC motors will be connected to the green sockets, which are labeled as M1, M2, M3 and M4. And I had to connect a battery to the DC jack connector for providing power. The breakout board also consists of an on-off switch, using which I can switch on and switch off this board. Now, like the previous motor driver, I also did not have to give separate 5 volts of supply to this breakout board as well. So guys, when you purchase a motor driver breakout board, please check its specifications and also verify whether you need to provide 5 volts of supply from your Arduino or not. That's it from this video. I hope from this video you would have understood what is a motor driver and how you can choose a good motor driver. Hey, what's up guys? In the previous video, we talked about the motor driver breakout board and the L293D motor driver IC. Now, in this video, I'll explain you the working of L293D motor driver IC. The L293D IC can control two motors at a time. It consists of a dual edge bridge motor driver circuit. That is, the motor driver IC consists of two circuits like these, one for each motor. Now, before I start explaining you the working of motor driver, let me explain you a very simple concept. So, if suppose you want to determine the number of input or output combination according to the devices you have, then there is a very simple formula for that. For example, in the first section, we have written a program to blink the LED. Now, since we had only one LED, there are two outputs possible. First, your LED will be high. Second, your LED will be low. So, from the LED example, let's look at the formula. Now, if you have one digital device, then your N is equal to 1. And the formula to determine the number of input and output combination is 2 raised to N. So, for N equal to 1, there are two outputs possible, that is high and low. Now, since we have to control a robot and our robot consists of two motors, then N is equal to 2. And so, the combination logic is equal to 2 raised to N, that is 2 raised to 2 equal to 4. So, for two motors, there are 4 input combinations possible. And these combinations are 0, 0, 0, 1, 1, 0 and 1, 1. That is low, 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 high, high, low and high, high. And when we apply these inputs to the motor driver from the Arduino, the motor driver will thus control the motors. So now, as you can see, this is an edge bridge circuit and this edge bridge circuit can control one motor. On the right hand side, there is a table indicating the input and output conditions. The input conditions of high and low are given from the Arduino to the input pins of the motor driver. And then from the output pins of the motor driver, the DC motors will be controlled. The edge bridge circuit basically consists of 4 switches S1, S2, S1 bar and S2 bar. And we need to give the inputs from the Arduino to these switches. On the top, there is a VCC pin and at the bottom, there is a ground pin. In the middle, there is a motor. And for this motor to move, the current should pass from VCC to ground. So first, if we give an input of 0, 0, that is S1 is 0 and S2 is 0, then the S1 and S2 switch will be open. Similarly, the S1 bar and S2 bar switches will be closed. So, since the S1 and S2 switch is open, the current will not flow from the VCC to ground, and at this condition, that is 0, 0 or low, low, the motors will stop. Next, if we give an input of 0, 1, that is S1 is 0 and S2 is 1, then S1 will be open, S2 will be closed. Similarly, S1 bar will be closed and S2 bar will be open. So, when we give a condition of 0, 1 or low, high, then the current will flow from VCC to S2, then to the motors. From the motors, it will go to the S1 bar and from the S1 bar, it will go to the ground. And in this case, our motors will move but it will move in the backward direction. So guys, at low high, the DC motor will move backward. Next, if we give a condition of 1 0, that is S1 is 1 and S2 is 0. So in this case, the S1 switch will be closed, S2 switch will be open. Similarly, S1 bar will be open and S2 bar will be closed. So guys, in this case, the current will flow from VCC to S1. From S1, it will go to the motors. From the motors, it will go to S2 bar, and from S2 bar, it will go to the ground. So guys, when you give a condition of high-low, the DC motor will move and it will move in the forward direction. And last, at the condition of 1 1, that is if S1 is 1 and S2 is 1, then in this case the S1 and S2 switch will be closed and the S1 bar and S2 bar switches will be open. So guys, as you can see, this condition basically represents a short circuit condition. So at this condition, that is 1 1 or high high, the motors will not move because the current will not be able to flow from VCC to ground. So guys, if we run through all the conditions again, then at low low, the motors will stop. At low high, the motors will move, but in the backward direction. At high low, the motors will move in the forward direction. And at high high, the motors will stop. Now guys, after understanding the conditions, let's look at a very simple example. If you connect pin number 3 and 4 from the Arduino to the D1 and D2 pins of the motor driver. Similarly, if you connect pin number 5 and 6 from the Arduino to D3 and D4 pins of the motor driver. Next, if you connect the M1 and M2 socket of the motor driver to the left motor, and if you connect the M3 and M4 socket of the motor driver, then when you write any command on pin number 3 and 4, the left motor will be controlled, and when you write a command on pin number 5 and 6, the right motor will be controlled. Now, as I've explained you earlier, if you want to move the motor forward, then the condition for that is high-low. So, if I want to move the left motor forward, then I will write high on pin number 3 and low on pin number 4. Similarly, if suppose I want to move the right motor backward, then I will write low on pin number 5 and high on pin number 6. So guys, I hope from this video you would have understood what is an edge bridge and how we can use the edge bridge to control our DC motors. So after understanding the working of motor driver, it is now time to connect the Arduino to the motor driver. First, I'll take 4 male to female wires for connection of motor driver to the Arduino. Now, for programming the robot, I'll be using pin number 3, 4, 5 and 6 from the Arduino. So I'll attach the male part of the wires to Arduino's pin number 3, 4, 5 and 6. Next, I will attach the other end of the wires to the input pins of the motor driver, that is D1, D2, D3 and D4. So, I'll connect pin number 3 from the Arduino to the D1 pin of the motor driver. Pin number 4 will be connected to the D2 pin. Pin number 5 will be connected to the D3 pin. And pin number 6 will be connected to the D4 pin of the motor driver. After this, I'll attach the DC motor wires to the M1, M2, M3 and M4 sockets of the motor driver. In the M1 and M2 socket, I'll attach the left motor wires. In the M3 and M4 socket, I'll attach the right motor wires. Now, for supplying power, I'll be using a battery snapper along with a DC jack connector. And as you can see, the DC jack connector has one positive socket and one negative socket. This is the positive socket where plus is written, and this is the negative socket where minus is written. So I'll connect the red wire from the battery snapper to the positive socket and the black wire to the negative socket. And once this connection is done, I'll attach the battery snapper to the DC jack of the motor driver. So guys, I've basically finished the connection of motor driver to the Arduino, and once you are finished with the connection, let's start with the programming.